Part B asks us to explain for what values of k we'll expect to see inflection points. Remember that inflection points come from the second derivative. So you have the first derivative, which is 2x plus, now the derivative, this is going to be a chain rule. Derivative of cosine is negative sine, leave the inside alone, times the derivative of the inside. So I might rewrite this as 2x minus k sine of kx. F double prime is the second derivative of this. Derivative of 2x is just 2. And we're going to have pretty similar here. We're going to have, so k, derivative of sine is cosine kx times the derivative of the inside, which multiplies by another k. So we have 2 minus k squared cosine of kx. Now, if we're going to have any inflection points, then we have to have places where the second derivative is either 0 or undefined. This is going to be continuous everywhere, so we're not concerned about looking for places where it's undefined. So we're going to specifically look for where the second derivative is 0. 2 minus k squared cosine of kx. Now, here's something important to remember. Cosine is never going to be any bigger than 1, right? So we have 2, and we're subtracting off k squared. Now, the only way to get this to be 0 is to have this be the same size as 2. In other words, 2 has to equal k squared cosine of kx. So, for instance, if k is 1, we end up with 2 equals cosine of x, which is not a true statement, hence why we have no inflection points. Since the biggest cosine can be is 1, if we take that into consideration, then we have to figure out what k is going to be in order to make this statement true. Well, k squared is going to have to be at least 2, which means k is going to have to be, at least. K squared has to be at least 2, which means k has to be at least square root of 2 in order for this thing to have inflection points. Now, when it does, it's going to have infinitely many. For instance, let's say we use square root of 2 for k. We are going to get 2 equals square root of 2 squared times cosine times the square root of 2x, which is going to give us, let me come over here a little, 2 equals 2 cosine square root of 2x. Divide both sides by 2, we get 1 equals cosine of square root of 2x. Well, cosine is going to be 1 at infinitely many places, so that's why we're getting infinitely many inflection points once k is rad 2 or larger. Conversely, if k is smaller than rad 2, we're not going to have any inflection points because, as we saw, this would not be a true statement.